Welcome to this first of a series of slideshows about fossils. Fossils are the remains, traces, or indications of life in the past. We start with the smallest. Any fossil that must be studied through a microscope is a microfossil. Here, the maximum dimension of a microfossil is taken generally to be less than 1 millimeter, 1,000 micrometers, although several larger forms are included in this category. This chart attempts to show that a micrometer, or its older designation micron, is indeed a very small length. A vast majority of microfossils was produced by plankton, the tiny plants, animals, and protists depicted on these slides that today, in many millions of billions, inhabit the upper 100 or so meters of the sea. But only a small moiety of these billions have any part of their integument or skeleton that can be fossilized. Listed on this chart are the 4 major categories of these remains. 3 are minerals: calcite, calcium carbonate; silica, silicon dioxide; and apatite, calcium phosphate. The 4th, perhaps the most widely disseminated both in time and in the succession of sedimentary rocks, is an organic acid-resistant material. It coats the cysts of phytoplankton, forms the lorikeet of most tintinnids, the tests of some foraminifera, the protective covering of spores and pollen, and it is also a major component of certain tooth-like fossils. Although its composition differs slightly among the fossil groups, this refractory material is always a complex fatty acid. Protists are plankton with most plant and animal characteristics. Here the term is taken to include protozoa, fungi, and some algae. On this slide are the microfossil groups called protists by the University of California Museum of Paleontology. Dimmed out are the red and brown algae not discussed here. Protists are but one of the many kinds of microfossils found in abundance in Phanerozoic sedimentary strata, and some occur in formations as old as mid-Proterozoic. Prominent among these very old fossils are acritarchs. Acritarch is a catch-all name for indeterminate microscopic remains presumed to be the resting cysts of marine phytoplankton, mostly green algae, or the egg cases of small metazoans. They are classified into form genera and form species according to their size, shape, and number and type of projections. In acritarchs, the fatty acid is called sporopollenin. Acritarchs are good markers in Paleozoic strata, but are less used thereafter, although they are still in existence. The development of their ornamentation in Proterozoic, Ediacaran, and Cambrian-Ordovician times is shown on this chart. Chitinozoans are flask-shaped microfossils and fossils, 50 to 2,000 microns, with organic walls of pseudochitin. Chitinozoans, too, are classified by shape, ornamentation, appendages, and processes into 56 form genera and over 1,000 form species. What they are is unknown, but the occasional finds of aperture to base chains, as shown on this slide, suggests that they may be the egg cases of metazoans, possibly of worms. Their range is late Cambrian to Devonian. In their range of occurrence, they provide good biostratigraphic information, for they change rapidly and have a nearly worldwide distribution. Fossil dinoflagellates are resting stage cysts, mainly of algae. Nearly all are composed of a resistant substance, dinosporin, but a few are calcite, and there are even rarer siliceous forms. Some cysts resemble the form of the motile cell without protrusions. They are proximate, but most species are more or less spherical, with processes that range widely in number and form. Those with many spines are said to be chorate. Dinoflagellate cysts occur first in strata of Triassic age and have been much used for correlation of younger Mesozoic strata. Many Paleozoic acritarchs may be unrecognizable dinoflagellate cysts. Shown on this slide of living species, tintinnids are protist zooplankton characterized by bunched cilia at the buccal end of a vase-shaped body called a lorica. These loricae are either an organic substance, sometimes agglutinated with foreign material, or a glassy hyaline calcite. Chitinous loricae occur in strata ranging in age from Ordovician to recent, but the fossil record is not continuous, so they are little used for biostratigraphy. In fine-grained limestones of late Tithonian, early Valanginian age, hyaline-walled forms called calpionellids flourished. Rapid evolution and widespread occurrence make the calpionellids excellent conostratigraphic markers in the limited range of their occurrence. Scolecodonts are the jaws of a marine annelid worm. They are chitinous, but may be partially mineralized. These worms were facies dependent, though their use in biostratigraphy is limited. The teeth are found in strata ranging in age from Ordovician to present. They are common only in certain levels of Paleozoic strata. The only hard parts of chaetognaths, arrowworms, are large, chitinous, circumoral grasping spines. The spines and impressions of the animal are found in appropriate Lagerstätten in the Cambrian strata of China, but their recognition in younger strata has been poor because the spines have been confused with those of the spine-like teeth of some conodont element. The only other confirmed fossil chaetognath is from the Pennsylvanian of Illinois. Other fossil denticles are much more prominent in the fossil record. Now called conodont elements, fragmentary tooth and jaw fragments of bone-like calcium phosphate occur in strata ranging in age from mid-Cambrian to late Triassic. These fragmented teeth and jaws are very common in Paleozoic shales, change significantly with time, and are readily concentrated. So for more than a century, they have been widely used as biostratigraphic markers. Recently, a number of these markers have been designated global standard sections and points, golden spikes. They mark the lower limit of several Paleozoic stages. Until 1983, the source of the 14 to 18 denticles that together comprise a complete apparatus were unknown. Then in Scotland and later in South Africa, fossils of chordate lamprey-like animals with a complete buccal apparatus were discovered. The impressions of these conodontophora range about 4 centimeters in length, while the conodont elements, tooth and jaw fragments, are commonly less than a millimeter. Learn a little about some of the calcareous and siliceous microfossils in part 1b. Hope to see you there.